Good afternoon, everyone. My name is Vivno. I am from CHG section. Today I am saying a tech talk topic about homogeneous equations in data science. In data science, a homogeneous equation typically refers to an equation in which the sum of terms is zero. For example, in linear algebra, a system of linear equations can be represented as Ax equal to 0, where A is a matrix and x is a vector of variables. When the right-hand side of the equation is 0, it's considered homogeneous. Homogeneous equation are important in various data science applications, including linear transformations. In machine learning and image processing, homogeneous equations are used to represent linear transformations such as rotations, translations, and scaling. Null space. In linear algebra, solving homogeneous equation helps us finding the null space of a matrix, which is crucial for understanding the properties of the system and for solving undetermined system of equations. Dimensionality reduction. In techniques like principal component analysis, PCA, homogeneous equations are used to find the eigenvectors of the covariance matrix, which in turn helps in reducing the dimensionality of the data while preserving the most important information. Understanding and solving homogeneous equations play a significant role in various data analysis and machine learning tasks. Homogeneous equations are fundamental concept in linear algebra. In data science, homogeneous equations are often used to represent relationships between variables. Solving homogeneous equations is essential for tasks such as dimensionality reduction and regression analysis. 2y square minus 3y plus 4y equal to 0. By the actual equations, 2m square minus 3m plus 4 equal to 0, with the two roots are 3 by 4 plus or minus root 23 by 4i. What are homogeneous equations? Homogeneous equations are linear equations where the right-hand side is 0. They can be represented in matrix form as Ax equal to 0, where A is a matrix of coefficients and x is a vector of variables. The solution of homogeneous equations are known as the null space of kernel of the matrix A. Homogeneous equation, the given equation 3x minus 5y plus 1z plus 2t equal to 0, minus 2x minus 3y plus 2z minus t equal to 0, x plus 3y minus z minus t equal to 0, and 2y plus z minus 3t equal to 0. Role of homogeneous equations in data science. In data science, homogeneous equations can be used to find patterns and relationships in data. They are used in machine learning algorithms for tasks such as a feature selection and clustering. Homogeneous equations are also crucial in solving overdetermined systems of equations. Solving homogeneous equations. To solve homogeneous equations, we typically use techniques such as Gaussian elimination or singular value decomposition. The solutions to homogeneous equations are not unique and form a subspace in the vector space. Eigenvalue decomposition is another method commonly used to solve homogeneous equations in data science. Applications of homogeneous equations in data science. Homogeneous equations are used in image processing for tasks like image denoising and inpainting. They play a key role in recommendation systems for collaborative filtering and matrix factorization. Homogeneous equations are also utilized in natural language processing for tasks such as word embeddings and document clustering. For example, determine whether the following homogeneous system will have any non-trivial solutions. 2x plus 3x2 minus x3 plus x4 equal to 0, x1 minus 2x3 plus 3x4 equal to 0, x2 minus x4 equal to 0. The existence of parameters in the solution guaranteed that there would be a non-trivial solution, in fact, an infinite number of non-trivial solutions. Theorem. If a homogeneous system of linear equation has more variables than equation, then it has infinitely many non-trivial solutions. Homogeneous equations in dimensionality reduction. In data science, homogeneous equations are used in techniques like principal component analysis (PCA) and singular value decomposition (SVD) for dimensionality reduction. They help in capturing the most important features of the data while reducing its dimensionality. Homogeneous equations enable data scientists to visualize high-dimensional data in lower-dimensional spaces. Homogeneous equations in regression analysis. In regression analysis, homogeneous equations are used to find the coefficients of the regression model. They are essential for estimating the relationship between independent and dependent variables. Homogeneous equations help in minimizing the error between the predicted values and the actual observations. Homogeneous equations in deep learning. Homogeneous equations are utilized in deep learning for tasks such as weight initialization and regularization. They play a crucial role in optimizing neural network architectures and improving model performance. Solving homogeneous equations efficiently is for training deep learning models with large amounts of data. Challenges in solving homogeneous equations. One of the challenges in solving homogeneous equations is dealing with ill-conditional matrices. Overfitting and underfitting are common issues that data scientists face when working with homogeneous equations. Choosing the right method for solving homogeneous equations can significantly impact the quality of the results. Use the method for solving homogeneous equations to solve the following differential equations. The given equation dx by dt equal to x square plus 60 and root t square plus x square by tx. And the next one is express the equation in the form of dx by dt equal to f of x by t. F of x by t equal to x square by t square plus 6 under root 1 plus x square by t square by x by t. Best practices for working with homogeneous equations. Normalize the data before solving homogeneous equations to avoid numerical instabilities. Regularize the solutions to prevent overfitting and improve generalization. Validate the results of homogeneous equations for cross-validation and testing on unseen data. Use the method for solving homogeneous equations to solve the following differential equation: dx by dt equal to x square plus 60 under root t square plus x square by tx. Express the equation in the form dx by dt equal to f of x by t. Future directions in homogeneous equations in data science. Advancements in computational techniques and algorithms will further enhance the efficiency of solving homogeneous equations. Incorporating deep learning approaches with homogeneous equations could lead to more accurate and scalable solutions. Research in utilizing quantum computing for solving large-scale homogeneous equations in data science is an emerging area of interest. In data science, a homogeneous equation typically refers to an equation in which the sum of terms is zero. For example, in linear algebra, a system of linear equations can be represented as Ax equal to 0, where A is a matrix and x is a vector of variables. When the right-hand side of the equation is 0, it's considered homogeneous. Homogeneous equations are important in various data science applications, including linear transformations, null space, dimensional reduction. Conclusion. Homogeneous equations are powerful tool in data science for modeling relationships and patterns in data. Understanding and effectively solving homogeneous equations are essential skills for data scientists and machine learning practitioners. In data science, a homogeneous equation refers to a linear equation. In the right-hand side is zero. These equations are common in various statistical and machine learning contexts. future directions in homogeneous equations in data science. When the right-hand side of the equation is zero, it considered as homogeneous equation. By leveraging the principle of homogeneous equations, data scientists can extract valuable insights and make informed decisions in various domains.